Hello everyone, welcome back to this channel. So today we are going to understand how to encode categorical variables. Some machine learning algorithms do not understand categorical data. They can work only with numerical data. So in that scenario, you have to convert your categorical data into numerical data. This conversion can be done in many ways, like label encoding, one hot encoding, ordinal encoding, and binary encoding. We will understand about all of this in details. Okay, now the first one is label encoding. Label encoding assigns a unique integer to each category. Like here you can see that the color red, blue, red, green. Every category will be converted to an integer. Red may be 0, blue may be 1, like that way. Okay. Now first let me copy this. Then you will be able to understand. Just run it and df. Simple one column that is color. Okay. Here I have imported label encoder. This is a class already written in sklearn library. So I have to just create an object of this class. So I write L equals to label encoder. Let's run it. Okay, now now I will create a column df column name uh, encoded underscore color equals to L dot fit transform on color column. Now if I run it, see if I show you the df, you can see encoded color, new column created, and red is 2, blue is 0, green is 1, blue is 0, red is 2, green is 1. So in this column can be understood by the machine learning algorithm. For some algorithms you have to do, not for every algorithm. Okay, so this is a simple conversion from a category to a numerical. This is known as level encoder, and it can be done by level encoder class, which is already in sklearn library. Fine. Now next understand one hot encoding. One hot encoding creates binary columns for each category. Like see here color the same data set. I'll just copy it and paste it here. Now if I do one hot encoding, then output will be like red, blue, green. All three categories will become columns. Now red means this one will be 1, but this will become 0, 0. Binary numbers. Blue will become 1. This will become 0, 0. Next one is green. So green will become 1. Next will become, this will become 0, 0. Blue is 1. So 0, 0. Next is red. So red will become 1, 0, 0. Green. So green will become 1, 0, 0. Okay. So you can understand. This has been encoded, binary encoded. This is known as one hot encoder. Now let's do it. Okay. So I will do on the same data set. So just copy this one. Paste it here. Import one hot encoder. Okay. Now just check the data set once again. df. It has color. On this column, we will apply this one hot encoder. Okay. Now let's write. Um, First, we have to create an object. So O equals to one hot encoder. Fine. Now I will write one hot encoded equals to O dot fit underscore transform on df, not on encoded color. We will do it on color. Okay. Now see what is the output. So I can copy. See the output. This is just sparse matrix. So I have to make it sparse equals to false. Sparse matrix means it has many zeros or missing values. So in that scenario, you have to write sparse equals to false. Now you can see 0, 0, 1, 1, 0, 0, 0, 1, 0. Now make it a data frame. Then it will look better. So I can write one hot encoded underscore df equals to pd dot data frame one hot encoded, and column names will be columns equal to o dot get feature names. Column names are feature names, so you have to get the feature names and make them the column names, because here you can see that three columns are generated, so you have to make them column name. Now if I print this one, you will be able to understand. Sorry, see, blue, green, red. Let me show you the data set. If I write df, red means 0, 0, 1, red is 1, blue, so you can see blue 1, green, so you can see green 1, others are 0, blue, so blue is 1, others are 0, red, so red is 1, others are 0, green, so green is 1, others are 0. Okay, so you get my point that all the categorical columns are converted into numerical columns and binary columns. Okay, this is what is done by one hot encoding. Okay, so now next understand what is ordinal encoding. Ordinal encoding means when you have an order. In that scenario, you will use ordinal encoding. Let me first copy the data set. See, this is the data set. If I write df, two columns, customer ID and their satisfaction level. See, satisfied, very satisfied, neutral, very satisfied, unsatisfied. So you can find that there is an order like low, medium, high, good, bad, average. They have an order, or education level like bachelor's degree, master's degree. In these types of categorical variable, you can apply ordinal encoding. Fine. Okay, so first I have to create categories. So let me first copy this one and run it. Now I will create an object O equals to ordinal encoder categories equal to categories. Fine. Now let's create a new column. df uh, satisfaction level encoded equals to OE dot fit transform and df on which column? Satisfaction column. So on that, this one will be applied. Now if I print this, just let me show it to you. See here. See, this is the satisfaction level. 3.0, 0.0, 2.0. Let me show you the data set, then it will be more clear. Customer ID, satisfaction level, encoded. 0.0, very unsatisfied. 1.0, unsatisfied. Neutral, satisfied 3, very satisfied 4. So you can see that there is an order. Whenever you get something like order, then you can convert it into this way. This is known as ordinal encoding. Fine. And the last one is binary encoding. Here it combines both level encoding and one hot encoding. What is done in level encoding? In level encoding, you assign an unique integer. In binary encoding, you create binary columns. Here both are done together. Let me first show it to you, then I will explain. Just copy and paste. Sorry, I have to install pip install category encoders. After it is done, then I can. It is not done yet. Here I am importing category encoders, named it as CE, and only one column New York, Los Angeles, Chicago, Houston. This is converted into a data frame. C, TF. Okay. Now initialize the binary encoder. So I have to write binary encoder equals to ce dot binary encoder. Now encoded underscore df equals to binary encoder dot fit transform on df. Okay, let's run it. Just see what is the output. See, this is the output. So CT0, CT1, CT2. Okay, now let me tell you how it is happening. This is a combination of both label encoding and one hot encoding. So in label encoding, first it will be converted into a number. So here, in this data set, just let me show you the data set first. New York, Los Angeles, Chicago, Houston. Okay, suppose to New York, I will give to New York, this is 0. For Los Angeles, 1. For Houston, it will be 2. For Chicago, it will be 3. And Chicago equals to 3. Just a unique integer. Okay. Now they will be converted to binary numbers. If 0 is converted to binary numbers, the value will be 0, 0. If 1 is converted, the value will be 0, 1. I hope you know how to convert this by dividing it by 2. Like 1 is divided by 2. If 2 is converted to binary, the output will be 1, 0. Do you know how to convert it to binary numbers? I hope you know. Everybody knows. No problem. If you don't know, just learn it. You have to divide it by 2. Now the remainder is 0. Now you have to consider it in this way. So it will become 1, 0. Okay. What is the output for 3? If you convert it into binary number, it will be 1, 1. Because if you divide 3 by 2, then both of them will become 1. Okay. Remainder will also be 1 and this one will also be 1. So if you write it 1, 1. Okay. Simple. First they are given in unique category. Then they are converted into binary numbers. Okay. That's what it is happening here. So 0, 0, 1, 0, 1, 0, 0, 1, 0 like this one. 0, 1, 1, 0, 1, 1 this one and 1, 0, 0. 1, 0, 0 means 1, 0. Okay. So these are the 4 types of encoding you can do. First one is label encoding, where you assign a unique integer. Second one is one hot encoding. There you create binary columns for each category. When there is an order, you use ordinal encoding. And when you want to use both of the label encoding and one hot encoding, you may do this binary encoding. Okay. Now tell me why to use this one, binary encoding. Because this is more efficient than one hot encoding when you are dealing with large number of columns. If there are many categories like red, blue, green, yellow, purple, many categories, for each of them, one column will be generated. So there will be so many columns. It will be a sparse matrix and it is always difficult to handle a sparse matrix. In those scenario, when you have large number of categories, you can use binary encoding. Okay. Because here it is first encoded into a number, then it is binary encoded. So that's why so many columns will not be generated. So binary encoding is much efficient than one hot encoding. Okay. So these are the ways you can transform your features from categorical to numerical variables. This is an important point of feature transformation. Okay. So meet in our next video. Till then, bye. Happy learning.